Hey, Ren. Good morning.
Good morning.
You know what? Because I have you just here, I just want to make sure you're okay with all the graded work, right?
Yeah.
Okay. I know I put some of the stuff in last night, and I think um, the written arithmetic sequence and series homework, you didn't send that in yet, right?
It's done. I'm not sure if I sent it yet.
Okay, no worries. I just wanted to make sure because obviously you would be one that would throw up a red flag. So it's not a big deal. Obviously, I just wanted to make sure I didn't miss something somewhere.
Okay.
So that's,
Mhm.
I'm going to wait just a couple more seconds, and then I'm recording. So at least that's good for everybody else.
Yeah.
Hi, Laura, Emma. Oh, wow, good. Carter, Hallie, Kayla, and Gus. I don't know how many of you were here when I was asking Ren. I was up late last night grading and getting things squared away. Make sure if I'm missing something, you let me know. Everything is still good to go. You can still turn everything in. I just know I had a question last night about the 12-1 no reassignment. And I had said, our benchmark was the 5th. So I kind of held off and waited to put anything in the grade book until then on the 5th, and it can all still get handed in. Just know that because I'm trying to keep us organized and on top of things, um, make sure that you guys realize that it can still be done. You don't have to wait for to hand it in. So it's not a 0, just hand it in and I'll update that. And then I'll update some of the rest of the information again next week. I know sometimes seeing 0s freak us out. I don't want that to be the case, but I also get emails asking how come this hasn't been updated? How come, what happened to the assignment, so on and so forth. So I got to try to hit somewhere in the middle, make sure people don't think I forgot, but also don't freak people out with grades. Um, the other reason, and I know I have you all muted so I don't echo. So again, remember when you want to say something, the whole point of this is so that we can kind of communicate a little bit better. One of the things that I want to take advantage of is to know what your opinions are, and maybe I'll put out a survey. May 22nd is essentially the day that we as a building are going to not be collecting, and I suppose that's probably the best way to put it, collecting any material for grading. Supposedly, as of the 26th through the end of the year, that's for us to make sure that anybody who has any late assignments, who needs help on correcting things, who needs help on understanding material more, can get that help if needed. I know that we have discussed the idea with the Honors Algebra 2 class that if this is something that you want, and I kind of alluded to it before, we'll keep going. That way you guys feel that you're prepared with material for next year with pre-calc or CCP, however you're getting graded on that. Right now, obviously, there's a lot of rumors just statewide as to how school is going to start next year. That's a long way away. So at this point, I want to make sure you guys are ready or at least comfortable. And so from the 26th through truly whenever, and by whenever, I mean if you need me through the summer, you let me know. And I am more than willing to hold sessions where we go over some of the material that maybe we did first semester, second semester, however you want to look at it, that you're concerned is going to impact CCP next year. And you want to make sure that you have a better understanding or more practice with that, as well as even finishing up what we would have gotten to essentially this year. So kind of think about that so that you understand kind of where we're at for the rest of the year. So obviously nothing new will be collected after the 22nd. and that gives everybody the opportunity to kind of get in late work, get caught up. Does anybody have any thoughts on that right now as we're here and can talk? Do you like that idea, kind of trying to keep going and rewind and review? Is that
Yeah, I
something
like
you'd
that.
be interested in?
Yeah, I am.
Okay. Anybody else interested in the idea?
Yeah.
Okay. Just kind of for the rest of us, think about it, because I do plan on sending out a survey here soon. I am going to email Mr. Colhan and see if he wants to do the same survey, because I know we had kind of discussed it at our meetings, so I want to make sure that we're all on the same page. So to get down to today, couple things when I went through the work we handed in. These two particular questions came up a couple times where the directions may have not been clear for some, and I want to make sure that we understand what we're looking for. For the majority of us, that whole assignment was pretty good. It was the 1 through 13, but specifically these two questions came up missed the most. So it does say, and this is going to be part of the geometric series homework, and it's essentially the same, and that's what we talked about on Monday. The formula just changes. So when we're looking at this idea for the nth term, what we're looking at is still using this a to the n equals the first term plus our common difference times n minus 1. And what we have to do is figure out what that formula is. Now I'm going to bring back this idea real quick. And we had alluded to that sometimes instead of writing it out like this, they give it to us in a symbol form with this sigma. And that sigma you're going to see a lot throughout the rest of your career with math, depending upon how far you go. And that always means sum. I know that when I taught stats, now granted decades ago, we used that a lot also in statistics. So it does cross over, not just sororities and fraternities. So here we want to figure out that our common difference, you can see that 9 minus 13 would be 6, 25 minus 9 would be 6. So we know that our common difference is going to be 6. We also know that our a sub 1, our first term, is 13. Now, because we're writing it for our nth term, we know n is going to be in this. So our a sub n would equal 13 plus 6 times n minus 1. And the whole point of this is to finish this equation off where you're going to distribute and then combine like terms. So if I want our final equation, we should leave it as 6n plus 7, and that would be our final answer. And I know that we did not have that happen. The next one is, at this point, the same. We're going to start with the same formula, except the information they give us does allow us to solve for a sub 1. So it does tell us that our nth term is a sub 5. And we don't know our a sub 1, but our common difference is 4. And down here is what n is. So we end up with 5 minus 1. So our a sub 5, which, excuse me, should be negative 12. I keep rewriting it because I'm saying it, should equal a sub 1 plus 4 times 4. And when we do subtract, we want to make sure, let's make sure we make that a negative. And when we add that to both sides, we end up with a sub 1 is 4. So when we do plug this back in, make sure that we have our a sub n. We now know what our first term is, and we know what our common difference is. And with any term, we want to know what that formula is. So if it follows the same pattern, we'll be able to distribute and we end up with a sub n equals negative 4n plus 8. So make sure that what we're looking at is still starting with this formula, using the information what we're given. So a sub n is now a sub 5. And then we end up filling in accordingly. So what I noticed is we were plugging in, but we weren't necessarily finishing out for any term in that pattern. So that's what those two are supposed to be. And I apologize, did somebody have a question? So I'm gonna ask the quiz. I looked at the data that was collected by the number of questions that were missed. And obviously, multiple choice seemed to have been the best answers, where like less than 4%, if anything was missed, it was under 4% missed the question. However, our short answers seemed to come back wrong. And so I was able to go back and kind of take a look at some of them. And those are the ones that I wanted to talk about very quickly. And if you looked last night, I made sure I had all of this ready. So if you wanted to, you can kind of, because I don't know if you can see the quiz again, but we wanted to know that the perimeter of this triangle. And again, this was just the distance formula from last year. If I needed a visual, I know that I could very quickly do 1, -3. And then I could do -4, 9. And -2, 1. Not quite sure how that works, but it's some kind of triangle here. But at least we can see that we have something along the lines of a triangle. We're gonna get rid of that because that sucked. But you can see that we're gonna combine those two. So our distance for the first one would be using these two. Our distance for the second side would be using these two. And our distance for the third side would be using these two. So we've got to do our distance formula 3 times. So -4 minus 1 squared, 9 minus a -3 squared. And then we have 12 squared. Well, I'm hoping that some of us might remember the Pythagorean triples. And it appears that a 5, 12, 13 right triangle, so even if I continued, I'd end up with 25 plus 144, which is the square root of 169, and that's where you see the 13 show up. So 5, 12, 13 does follow the pattern, because remember the distance formula is your Pythagorean theorem. If we did the distance formula over here, -2 minus our -4 plus 1 minus 9, and we end up with -2 plus 4, or 2 squared, and -8 squared. So 4 plus 64 would be 68. And that's going to give us a 2 radical 17. Last, -2 minus 1, 1 minus our -3, and we end up with 4 squared here. And again, kind of similar to this, 3, 4, 5, we find out the distance for this one is 5. So when we write our final answer, you have to remember that this is a compound answer where you can add your like terms here, and you would end up with 18 plus 2 radical 17. And so I'm not sure how that worked out for some of you. Again, because we shared the quiz, the percentages may be better for us and less for them. I don't know. But I just want to make sure that we did see that even if you drew the picture as crappy as I did, that it's just combining the sets of numbers. So that seemed to have been one that was an issue. And I don't know if it was just a matter of how to type it in, but I wanted to make sure that we did discuss that one. Any questions so far? I'll assume silence. That was a good thing. So the last one was this one. And again, it could just be that we're uncomfortable plugging things in. I don't know. But we had one where it was a segment AB with a center O, and we wanted to find where that center O if the segment was the diameter. So that would be finding the midpoint for the center, which would be -6 plus -3 divided by 2, -2 plus 4 divided by 2. And this would end up being -4.5 or 9 halves. And this would end up being 1. -2 plus 4 is 2. 2 divided by 2 is 1. So again, I'm not sure. And I know when we put in the answers, we did include the option to do not just -4.5, but we also did -4.5. We also did -9 over 2. So there were options for how we plugged that in. We also had options for if we put spaces in between, because I know that's an issue with how we type it in. So we had like 7 or 8 different options for how you would plug that value in. So again, not sure if the negative signs cause some issues. Distance, again, -3 minus a -6 squared plus 4 minus our -2 squared. We end up with 3 squared plus 6 squared. And this ends up being 9 plus 36, which is the square root of 45. And when we do our answer for this, we would have to have 3 radical 5. So again, knowing that you'd have to type that in and using some of the other questions that were on the quiz, you would have the square root, and we had the variations of how that could get plugged in. So it could be that if for some reason you feel that you had any one of those right, and I didn't seem to find it going through individual papers last night, please make sure that you email me or you let me know, because I want to make sure that I do get you those points back. I know how hard some of us work, and I get it could be frustrating with the current grading scale. Please be patient with everyone. Obviously, this is never something we ever thought we would be planning for. So it is obviously difficult for everyone, but I do want to make sure that you understand that I am very aware of how hard some of you are working, and you should all be very proud of that. So I do want to make sure if I miss something that I do update it accordingly. So if for some reason those questions you feel you got correct, I will take a closer look at your individual quiz. So far, so good? Okay. So I want to go back to what we did on Monday. I have a couple of examples here that I would like to make sure we worked through just to kind of talk it out before we end for the day. When we want to do our geometric series, again, remember that's our sequence, so our list of numbers that we talked about, and we did talk on Monday about 5 words, 5 tags, and how fast that does increase. And it is very true, like it will increase, and that's one of the examples I saw in the book, I think it was this domino effect, where one domino will knock over 2, and then each of those knocks over 2. And it has this exponential growth. And that's why in part of our formula, you see an exponential formula involved. So in this one specifically, just like our arithmetic example, we want to make sure that not only do we recognize sum, but it does specify geometric series. So we do want to make sure that we use one of the 2 formulas depending upon what's given to us. So in this first example, we see a sub 1 and we see n. So we had a separate formula for when that information was given to us. And that formula was our s sub n, so our sum of however many terms our series has, the a sub 1 plus, minus a sub 1 times r to the nth over 1 minus r. So in this case, we have 2 minus 2, our r, which is 3, raised to the 10th power, all over 1 minus 3. Now, when we plug that in and we take 3 to the 10th, we end up with 2 minus 2 times 59,049, all divided by -2. If I plug all of that back into my calculator, I have negative 118,096 divided by -2. So our S sub 10, so the sum of that series is 59,048. And again, all of this is based off of what the directions tell us and what information is given. So sum or geometric series tells me I'm going to use one of 2 formulas. This information specifically tells me which formula to choose. So then when we do the next one, we're going to still do the sum, but we have to take a look at what values are given. And because we're given a sub 1 and a sub n, our formula adjusts. And what we're looking at now is our formula a sub 1 minus a sub n times r over 1 minus r. So when we plug all of this in, we have our 2,000 minus 125 times that half, divided by 1 minus a half. And we end up with an S sub n this time of 3,875. So when we look at the questions again, look at the directions, see what's given, decide which formula, and then again, this time it's a plug in and solve. Now, I will bring back very quickly because the sigma notation does look confusing, feels confusing, sometimes a little overwhelming, but when we did it with our arithmetic information, we said that in this notation, the bottom number tells me what first term I'm going to use. And the K isn't the first term. The K equals tells me what do I plug in to find that first term. So here it told me that I was going to plug in 1. I worked it out to find the first term was actually 4. And then we're going to plug in the number 2, and then we're going to plug in the number 3, and we're going to keep going until we plug in the number 10. So what this tells me is what values do I plug into the function to then find the values of my sequence. This was the first term that I was going to plug in to find the actual values of my sequence. This was the last term of what I was going to plug in to find the values of my sequence. At this point, this function tells me whether it's arithmetic or geometric. If it's arithmetic, we know we're going to be adding things. But if it's geometric, you'll see that we're going to use the same notation here. But even though it's the same notation, the first term that we're going to plug in to find what value our sequence starts with, the last we're going to plug in to find what our sequence ends in, it's this f of x that tells me if it's arithmetic or geometric. And so when I look at this example down here, this example down here still has the summation symbol, or sigma, tells me what I'm going to plug in first to get my first term of my sequence. This tells me what the last term would be. And this tells me what the actual formula is, that f of x formula for the series. Now, the nice part about this is you can see right here that this base, notice how there's no addition or subtraction here. This is our exponential function. If I hit everything here, that's our exponential function. So that base value is actually our common ratio, our R value. We know this is our first term. So when I plugged in 3, I was able to find that a sub 1 came out to be 16. If I counted how many positions there's going to be in my sequence, from 3 to 10 is 7. But remember, we've got to count the spot that 10 falls in. So that's why from 3 to 10, there's actually 8 spots. And I know that they talk about taking 10 minus 3 plus 1 so that you remember to count that last position. Well, the nice part about our geometric summation, our series, is if we have a sub 1, r, and n, it tells us right away what formula we're going to use. So we don't have to find the common difference like we did with the summation for arithmetic. So again, our r value is this guy. Our a sub 1 is what we plug in with that first value. And our n is always how many positions are covered in that sequence. So then I can just plug that in and find the sum of this. So instead of trying to cram all that in there, there's that example. So when it says find, this symbol means find the sum of a series. Now again, I don't know if the series is arithmetic or geometric until I look at the equation. The f of x tells me if it's arithmetic or geometric. And this one is a geometric series because of our multiplication, not addition. Then what I also need to pay attention to is this guy will tell me the a sub 1. Whatever that first term is, it told me that I wanted to plug 4 in here. So 1/4, 3 raised to the 4 minus 1 is 1/4 times 3 cubed. And a sub 1, you could leave as 27/4, which is in fact 6.75. So either or works. It appears the majority of them are decimals, but either one works. And the last thing that we need to worry about is how many places is this sequence going to have? Well, 12 minus 4 plus 1, because from plugging in 4 to plugging in 12, the difference here is 8, but we have to count that last spot, so that's why it's 9. So our n is 9. And because we have a sub 1, n, and over here, remember our common ratio is always the base of our function. R is 3. With those 3 values, you now know that you're supposed to be plugging it into the formula S sub 1, A1 minus A1 times R to the n all over 1 minus R. And at this point, it's just reading what it's telling you and matching it with the right formula. So we have 6.75 minus 6.75 times 3 to the 9th, all divided by 1 minus 3. I didn't write that down. And S sub 9, because that's what n was, $66,426.75. So again, depending upon what the situation is, what the scenario is, this could be any exponential growth situation. So I wanted to make sure that we looked at how to read the sigma notation, what each of those parts were, and to recognize that even though this is geometric, that this setup is for either. So it does work for arithmetic or geometric. It's the function that tells us which one it is. So once it's geometric, we have to choose between 2 formulas. That's all I have for you for today. I wanted to make sure that we went over both of the items, the review material from the past couple things, and then finish off the geometric series section. I do plan on giving you some practice with the geometric series, and I'm going to ask this. So I am going to ask for some feedback. I have, I don't know if it's pulled up. No. I have a written assignment out of your book, which would again be, I think, off the top of my head, um, 10 to 15 questions, 10 questions that would be on the geometric um, series. Would you prefer the written work or no read that you can, if you're having issues, you can do the step by step, the videos, what have you? I just want to kind of have some feedback to know what you would prefer to practice this.
Honestly, I prefer the written work because I feel like on no read I don't really understand the questions sometimes, and then I get them wrong because of that.
Okay, we can do that. Does anybody else have any feelings?
I'd rather do the written work as well.
Okay, so what I'm going to do is I'm going to put together probably 10 questions. It could very well just be out of the book, and I'll tell you which 10 to pick. But I do plan on Friday, whether you watch a video or you join me, um, doing a couple actual, like, where would we use this type situation? Because obviously, if there is anything that would be pertinent in data collection specifically, if we find these patterns, and depending upon if they're arithmetic or geometric, because we did look at some arithmetic stuff, it's not just plug into a formula and be done with it and just practice number crunching. There's a purpose for where this gets applied to, so I'd at least like to show you why it's important. So again, whether you join me on Friday or you watch the video, just make sure that you do take a look at why it's important. Again, it will help us in the future depending upon what your choice is for next year or for the future. Are there any other questions or comments that I can address while we're live time and not 20-second delay? Okay, I just wanted to make sure. Again, please check if you're concerned about anything and drop me an email. Make sure that I have found everything, or if for some reason you think you did okay on that quiz and you didn't get a perfect score, or you thought you answered something right and for some reason you're not sure why your score, I have absolutely no trouble going back and looking at your quiz individually, just to make sure everything was accounted for. And then we can even, whether it be email or Zoom, we can chat about what the issue may have been. So check Google Classroom as always, because I'll probably have a survey out as well for what the rest of the year and summer will look like, and we'll go from there. So check the classroom. I'll have written work up here shortly, before the end of the evening, and what that due date should be tried to reach by so that we stay on task and we're not falling behind. But looks like there's a little bit of sunshine out, so go enjoy your day, relax a bit, and have a good day. Bye, guys.